Hello.
Hello,
Hello,
sir.
sir.
Yeah. Uh, you were doing the theory, right? Functions and all. Correct?
Yeah.
Yeah.
We had almost done the theory, I think. So I just wanted to discuss some problems. Uh, did I give some homework or something?
Yeah, you sent a practice sheet.
Yes, sir. I
Theory, theory part and types of functions and all is done, right?
Yeah.
Into, onto, one, many one, all of that I've discussed.
Yeah.
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 Yes.
Okay, 1 second. You have some doubts in the practice sheet.
Yeah, I have.
Yes,
Yeah.
sir.
1 second. This is the Plances thing, right? What is the sheet name? Where is it?
Functions
Doesn't have
to
any name.
the
It
dot.
It
just
Doesn't
reads
have a name.
function.
doesn't
Yeah,
have a
it's
name.
untitled function.
It just
Yes.
have
It's, I
exercises.
think the
Then
Yeah,
it
the
yeah,
one level
like
two
level one.
exercise.
okay, okay. 1 second. Okay. Oh yeah, it is Fitji. Okay, fine. Tell me, what are the doubts?
I have a doubt in the second question.
Domain of this
Yeah.
fx is equal to sec inverse this thing. Okay. Uh, fx is equal to sec inverse this. So you have to understand when is sec inverse defined, right?
Right.
Basically, that is what you have to understand here. Cos square x will be between 0 to 1, right?
Yeah.
You cannot give an input. So obviously the only possibility is 1, right? Cos square x has to be 1. That's all. Why am I saying
Okay,
that?
right. Yeah,
Sec
yeah, yeah.
inverse
Okay,
x
yeah,
cannot
yeah.
be less than
It
1.
can't be. Yeah, because it's one by cos. So and cos lies between -1 and 1. So any value between 1 and -1 will obviously be greater than 1.
Yeah.
Yeah.
So
Okay. Sorry. Yeah. Got it.
the only way you can get it is when cos square x is 1. Is everyone
Yeah.
understanding?
Yeah.
Yeah. Yeah.
Yes, sir.
If you have a function like this, y is equal to sec inverse cos square x, then sec inverse function is defined only when the inside part, whatever it is, must be greater than 1 or lesser than -1.
Hmm.
So actually here what you have to ensure is that the input to the sec inverse function, which is cos square x, should either be greater than equal to 1, it cannot be less than equal to -1. So it cannot even be greater than equal to 1, so it has to be equal to 1.
Yes.
So the domain will be all points where cos x is plus or -1. Cos x will be plus or -1 at 0, at pi, like all integral multiples of pi, right?
Right.
X is equal to m pi, right? Every integral
Yeah.
multiple of pi, you will get cos x as either +1 or -1.
Yeah.
So that will
Right.
be the
Got it.
answer for this one, finding the domain of this,
Yeah.
right?
Got it. Yeah.
Then what is the next one?
Sir, in the eighth question,
Hmm.
like,
Eighth question, yeah. That is a solution of an inequality, right?
yeah. So, in the answer key, it's given A,
Hmm.
but then if x is 3, then like
X is
it should
3,
be
then
greater than 0, right?
it should be greater than 0. So yeah, it will be equal to 0. So that will be wrong.
Yeah.
So it should be
Correct.
B, right?
It should be B.
B. Yeah.
But then the
A
answer
is
is
wrong.
given A.
It could be wrong, dude. Fitji can have wrong answers sometimes. It's
Okay,
fine.
okay.
Hmm.
Whatever is work commonsensical, that is correct. 3 cannot be true here.
Yeah.
So
So
can you do the seventh one?
which of the functions are invertible? So what is the theory for invertible functions? When can you have invertible nature of
One,
functions?
two,
1, 1 on 2.
yeah. One, one.
So it has to be 1, 1 on 2,
Yeah.
because otherwise it will not satisfy some condition of being a function.
Hmm.
If it is many one, it will be having multiple values for the same one, the inverse.
Same. Yeah.
And if it is into, then it will not be a function because some elements will be left out from the domain of the
Right.
inverse.
Right.
Yeah.
So you have to first think about whether it is 1, 1 on 2 or not. F of A to A is -1 to 1. Okay. F of A to A is -1 to 1. and you have to check which of the functions are invertible. Okay, first function is y is equal to x by 2. It is clear that this function is 1 1.
Yeah, it is one.
Why? Because it is constantly increasing.
Yeah.
Yeah,
Its graph is like this, and if it's an increasing function, then throughout this domain it is increasing.
yeah.
So it has to be 1 1.
Yeah.
And clearly it will be onto, because
Onto.
codomain is this and range of this will be itself, right? So A only.
Yeah. Hmm.
So this is invertible. Then we look at the other functions. The other
C
functions is
definitely
b
not.
sine pi x by 2, right?
Yeah.
So sine pi x by 2, suppose. Okay, first of all, C and D are
C
gone,
and D is
right?
definitely not.
Yeah.
Yeah.
Because there are many one. B is the only other thing that we have to look at. Y is equal to sine pi x by 2. So if your inputs to this function is from -1 to 1, so basically you are going from minus pi by 2 to pi by 2, right?
Correct.
The input to this function is from minus pi by 2 to pi by 2. That
Yeah.
is fine actually, because sine is increasing in that range,
Yeah.
like this. Sine will be increasing in that range at least.
Yeah.
So that's fine. Then is it one? It is 1 1. Is it on 2? Let's think about that. Uh, range is equal to codomain is happening for this. Yeah, it is invertible. B is also invertible.
Yeah.
Both A and B are
Yes.
invertible, I think,
Yeah.
because sine outputs here will go from -1 to 1, and that is the same as the codomain.
Right.
Yeah.
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 So range is equal to codomain, and function is increasing in this region. So therefore, it will be 1 1 also, right?
Yeah. Yeah.
Yeah.
So both A and B seem to be right. C and D are definitely wrong.
Hmm. Yeah. Yeah.
What else?
So the 10th question.
10th question. F, f of x or fx, I think. Fx is a function that is, it is fx, I think. So is a function that is odd and even simultaneously. Means it's a constant function 0. No? C. Answer is C.
Oh.
Hmm. Yeah.
How can it be odd and even simultaneously?
Right.
F
Oh,
of
okay.
x
Okay.
is equal to f of minus x, and f of minus x is equal to minus of f of x. I mean, this is
Okay.
odd, this is even. This is not possible unless fx is 0,
Right.
Right. Okay. I got it. Yeah.
right? So
Yeah.
it's a constant function, so answer will be 0. Then
14th one.
which one?
14.
13th one. Which one?
14. 14.
14. Okay, the period. So period is something that we have not discussed, I think, right? Have we discussed period?
No. No. I don't think we did
No, we
because.
didn't. Oh.
Period of a function is basically the smallest value, say let's call it t, such that f of x plus t is equal to fx for all possible x. Basically, it is the smallest number where after which you start to see repeated values.
Yeah.
So, for example, if you think about it, sine of x plus 2 pi is equal to sine of x no matter what x is.
Yeah.
Right. Yeah.
I mean, this doesn't mean that uh, values other than this t is equal to 2 pi will not ensure repetition. Okay. Because you can say that sine x is also equal to sine of pi minus x, right?
Yeah. Yeah.
Yeah. Yeah.
But
Right.
the problem is that that will fit only for one particular value, right?
Yeah. Yeah.
Like, for example, if you, I mean, I have to construct a better example. What I mean to say is basically that if you add t to the function's input, right? Then no matter what your x is, it will repeat. It will be the same. However, if you add pi, suppose sometimes with pi also sign could have been same, right? Like not pi. Suppose sine 30 is half, right?
Hmm.
Yeah.
So sine 150 is also half, right?
Yeah.
Correct.
So somebody could have made the claim that pi by 6 this is, and this is how much? This is 5 pi by 6.
Correct.
So somebody could say that wait, 4 pi by 6 is my period. 2 pi by 3 is the period, right?
Oh.
Right.
But that is wrong because it will fail for sine 70 degree. If you add 120 to that, it will become 190, right? So it will come negative sign now, right?
Yeah, yeah,
Correct. Correct.
So 2 pi by 3 cannot be the period because 70 degree will fail, right?
Yeah. Yeah.
It will be a period only if it is true for all possible
All the,
x's.
yeah.
yeah.
The smallest value that is such will be 2 pi. The smallest such value for sine will be 2 pi here, where no matter what x you pick, it will be the same, right?
Yeah.
Yeah.
The
Yeah.
smallest value t such that f of x plus t is equal to fx for all possible x. That is the period of the function fx. Now you have to understand that sometimes if you have a combination of functions, suppose sin x plus cos 2x, let's try to find the period of this. So we know that sin x period is 2 pi, cos x period is also 2 pi, and tan x period is pi. How do we know this? That tan x period is pi?
Because the
Because graph repeats after
after
every pi.
pi. Yeah.
Yeah.
So we know these standard basic periods of normal trigonometric functions. So first thing that we should do is find out the period of cos 2x here. Cos 2x is basically going to have a period of pi. Why pi? Why not 2 pi here? Because if you input some k times x, right, you are basically stretching the x coordinate by k times, right, x axis.
Yeah.
So think about it. If I have a sine graph normally is supposed to be like this, right? 0 to 2 pi.
Yeah. Yeah.
Right.
But if I have sine 2x, right? I don't have to go to 2 pi to get the full variation, right?
Yeah.
Even if you go from 0 to pi only in x, you should get the full variation of sine 2x, right? Sine x.
Yeah. Yeah.
Yeah. Yeah.
This is the graph of sine 2x.
Hmm.
So it, because you have to go only till pi to see the whole sine curve variation, right?
Right.
Yeah.
Because values will go from 0 to 2 pi, right? If you go from x from 0 to pi, right?
Mm-hmm. Yeah.
So multiplying the x with some k constant basically shrinks the graph or contracts the graph.
Yeah.
How many times? By k times. 1 by k times it contracts, right?
Yeah.
So then the
Right.
period of the sine becomes pi only. Na? This period becomes pi, right? Because it will start repeating after pi now,
Yeah.
right? You will have another graph like this.
Yeah. Yeah.
However, if I had
Correct.
if I tried to draw the graph of sine x by 2, think about it, it will be stretched twice. This is normal sine x by 2 will be like this. Because you have to go till 4 pi to get the whole variation now, right?
Right.
Yeah. Yeah.
Right? 0, 2 pi, 4 pi. Only if you go till 4 pi will you get inputs ranging from 0 to 2 pi, right?
Yeah.
So now this is a stretching of the graph by 2 times, right? So
Yeah.
basically,
Yeah.
if the period of sine x was 2 pi, period of sine x by 2 will be 2 pi by half, so 4 pi.
Yeah.
So the
4
logic
pi. Yeah.
is that
Got it.
if you have function fx has period t, then function f of kx will have period t by mod k,
Yeah.
right? And this is clear from the graphs of the functions. So you should understand that part. So Now I have a combination of two functions. One function has period 2 pi, one function has period pi, right?
Yeah.
Correct.
Whenever you have a combination of multiple functions, generally the LCM of the two will be the period, common period. Because after an LCM, both will repeat at once, right?
Yeah.
Yeah.
Right.
Like you cannot do just one of them repeats and just the other one repeats, right? You have to ensure that the entire thing repeats, right?
Yeah.
Yeah.
So you have to take an LCM. It's like multiple people are marching. One set of people are marching at one rate, another set is marching at another rate, right? So you have to
Correct.
match their rhythms, right? So you'll have to take LCM,
Yeah.
after which everything will be the same again, right?
Hmm.
So the LCM of this pi and 2 pi will be 2 pi, and that will be the period of the overall thing, right?
Yeah.
Yeah. Okay.
So in general, this is how you do these questions. You have to think about the smallest possible value after which the entire thing repeats, right?
Yeah.
Yeah.
For example, now if you take the function fx is equal to mod sin x, now what is the period of this function? Mod sin x, look at the graph of the function to understand. Sin x graph would be like this,
Yeah.
but mod sin x graph would be just,
Just the negative part will be reflected.
Yeah. Yeah.
so clearly it is repeating after pi, right?
Fine. Yeah.
Yeah.
So mod sin x period is pi. Similarly, mod cos x period will be pi, right?
Yeah.
Yeah.
Right.
Mod cos x will also be pi. However, if I construct the graph of mod sin x plus mod cos x, right? This function, there are sometimes special cases where that LCM rule sometimes fails to work, because if you look at the graph of this, you will realize that both have period pi pi individually, but when you
Yeah.
add, the period becomes pi by 2. You should check the graph of mod sin x plus mod cos x. It will start repeating after pi by 2 only. So put some values and check. If x is equal to 0, what is gx? Gx is equal to 1, right?
Yeah.
If x is equal to pi by 2, what is gx? It's still 1, right? But one
Right.
value cannot convince you, so you take some other values also. So if x is equal to 30, let's say, gx is equal to sin 30 plus cos 30, so root 3 plus 1 by 2, and add 90 degree to it. So if x is equal to 120 degree, right? What will that be? Again, it will be root 3 by 2 plus 1 by 2, right?
Right.
So basically, this is, you don't have to wait till pi to get a repetition here. You can get a repetition only at pi by 2. The reason this is happening is that the graphs of sine and cos are slightly shifted, right? This is sine, this is cos, right?
Yeah.
Yeah.
Cos mod cos x graph is like this, mod sin x graph is like this. So the
Yeah.
addition will be this plus this at the same point. So it will be high point here, and at pi by 2 you will get a high point again, right?
Yeah.
Mm-hmm.
Pi by 2 should come back to the same level,
Yeah. Yeah.
right? Notice that every pi by 2 it comes back at the same level, right? So I mean, you can draw a graph, however, it's just that uh, first of all, it is not becoming zero ever, right?
Yeah.
Because
Mm-hmm.
both will not be zero simultaneously,
Yeah.
right?
Yeah.
It's
Correct.
not becoming zero ever, and it is becoming pi by 2 at certain points, correct?
Yeah.
And after, you can see for sure that every point which is pi by 2 separated, it is actually same, right? Here also
Yeah.
like 1.
Yeah. Yeah.
So the intermediate graph will be not simple, I think. I mean, you'll have to just check values and plot them, but I will not do that. I just know that some cases you have to be a little careful with that LCM rule.
Right.
Right. Yeah.
Individually, you can be pi and pi. Answer is not pi, answer is pi by 2 in this case
Yeah.
Yeah.
for
Yeah.
the period.
Right.
So You just have to be careful and go through the graph of the functions to be able to understand. Now we can look at the question. Question is period of this. Period of sine n of x, sine n of x by tan x by n, where n is an integer.
Yeah.
By tan x by n, where n is an integer, is 6 pi. He has said n belongs to integer, period is 6 pi. Okay, period is given as 6 pi, then n is what he is doing,
Yeah.
right? So, okay. Period of the numerator is 2 pi by n, right?
Yeah,
Yeah.
yeah,
And period of the denominator is n pi, right? Because pi by 1 by n.
Yeah.
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 Okay.
Right.
Combined period of the function is 6 pi apparently. So, okay. So let's take LCM of these two. LCM of 2 pi by n and n pi by 1, right? Is equal to 6 pi apparently, right? Now
Yeah.
LCM of fractions is LCM of numerator by HCF of denominator.
Correct.
Okay.
Okay.
Whenever you have fractions like a by b, c by d and all, right?
Yeah.
LCM of a by b and c by d is LCM of a and c by HCF of b and d. Okay. So LCM of this and this, right? We'll just write it LCM of 2 pi and n pi divided by HCF of n and 1 is simply 1, highest common factor, right? So LCM
Yeah.
of 2 pi and n pi is equal to 6 pi, right? This is the
Yeah.
period. So then n is equal to 3, right?
3 pi. Yeah.
N is equal to 3 will fit. Correct.
Yeah.
3 definitely fits. So I'll just go with 3, right?
Yeah.
You could have thought about it in a slightly different way also. You could have thought about what is the value of n that will satisfy this equation. Sine of nx plus nt by tan of x plus t by n is equal to sine of nx by tan of x by n, right?
Yeah.
T is the smallest possible value for which this is true,
Yeah.
right? And actually t is 6 pi. Just put 6 pi for t, right?
Yeah.
Yeah. Yeah.
So 6n pi plus nx, right? And 6 pi here by n. So 6n pi will make sure that it is sine nx only on top,
Yeah.
right? So you can cancel the sine nx part from both sides, right? And you will get an equation saying tan x by n is equal to tan of x plus 6 pi by n, right?
Yeah.
Correct. So x by n should be equal to n pi plus this, right?
Right.
Yeah.
M pi, mi is a different integer by this, right? This is
Yeah.
the
Right.
general solution. So you should get something like, okay, that doesn't work because n pi plus alpha, okay. There is some cancellation that is happening, unfortunately. Okay, maybe I think the LCM HCF method was only better. Slightly more complicated this is becoming. I think we should not have cancelled this factor also. But yeah, normally what you're doing is finding out the periods of individual functions and taking LCM and
Yeah.
LCM of it.
Yeah.
So here the individual periods were 2 pi by n and n pi, right? Okay, so we got that. Next one is what?
Sir, I have a doubt in the 11th one.
Fx and gx are two given functions with all real numbers as their domain. Then, okay. Now, you just have to write your hx. Hx is simply fx plus f of minus x and gx minus g of minus x. You have to find out whether hx is even, odd, stuff like that, right?
Yeah.
So you need to know what even, odd is. That's all. After that, it's easy. Put h of minus x and see what happens. It becomes f of minus x plus f of x, and this becomes g of minus x minus g of x. It's obviously negative, no?
Right. Yeah.
So it is odd. There is no problem here. You just put h of minus x, see what is the connection of that to h of x.
Yeah.
Oh, okay. Yeah, right. Got it.
Yeah.
Just definition. What else?
So the 15th one.
Okay. 15th one is another period question.
Yeah.
Now, okay, fx is one function is given as fractional part of x. Fractional part of x plus sine ax, right?
Yeah.
And they have given some information about, okay, this whole function is periodic is given. Then what about a? Then say something about a. This is periodic. Then what can we say about a? Right?
Yeah.
So individually period of this is what? 2 pi by a.
Yeah.
Yeah.
Right? And think about fractional part function. Fractional part function is basically x minus gif of x, right?
Right.
Is
Yeah.
equal to fractional part of x, right? Correct.
Yeah.
So the graph of fractional part function, let's try to draw that graph. So this is say 0, 1, 2, 3, and so on. This is 1, 2, 3. So x minus gif of x. In this portion, it will be simply x, right? In 0 to 1, gif of x is 0. So
Yeah.
fractional part of x is equal to x, right?
Yeah.
Yeah.
In 1 to 2, it will be x minus 1 graph, right?
Right. Right.
Correct. In 1 to 2 portion, x minus 1 graph starts from 0 again, right?
Yeah.
You understand? This graph is basically x minus 1 in 1 to 2. Correct?
Yeah. Yeah.
Sure, no? You understand how the graph is being made.
Yeah. Yeah.
Yeah.
Again, 2 to 3, it will be x minus 2 graph, which will
Yeah.
be like this.
Right.
So you're
Yeah.
seeing a pattern that the fractional part function is like this series of things like this, right?
Yeah.
Right. Yeah. Yeah.
Okay, wait 1 second. It's correct, no? X minus 1 graph is this only, no? Yeah, it is. Yeah, it's fine. So clearly the common period is 1, no?
Yeah.
Yeah. Yeah.
It repeats after 1 units.
Yeah.
Right? So period of this is 1, right? Now the overall thing is periodic, means we have to take LCM of this and this,
Right. Yeah.
correct? So this is a rational number and this is irrational, right?
Yeah.
LCM of rational and irrational will not be possible unless this also becomes somehow rational, no?
Rational, yeah.
Like, how will you take LCM of lowest common multiple of rational and irrational, right? Irrational numbers multiple should be irrational, and rational
Yeah.
numbers multiple should be rational,
Yeah.
right? So the only possibility is so that somehow this is also rational, right?
Yeah.
That can happen if A has some pi or something,
Yeah.
right?
Yeah.
So A has to be at least irrational and have a pi, right? So that it cancels off the pi in the top, right?
Yeah. Yeah.
Yeah.
Therefore, answer will be A is irrational.
Right. Yeah.
A is a rational multiple of pi. See, that is
Of
correct.
pi. Yeah.
So that is fine, because then the multiple of pi part pi will cancel and rational number will be left.
Yeah. Yeah.
Okay. What else? Is there any other problem
Sir, question number 45.
in this level 1 only?
Yeah.
Which of the following functions is R periodic?
Sir, how do we find out for the first option?
So first option is a special function. You will see it in any standard books theory. It's called Sgn Signum Function. It will be there in whatever your coaching books, and every normal coaching book and all will have it. So Signum function basically means, it is called Signum function, and it is defined as Sgn of x is equal to basically x mod of x by x if x is not equal to 0, and 0 if x is equal to 0. So sometimes it is also written as 1 if x is greater than 0, 0 if x is equal to 0, minus 1 if x is less than 0.
Right.
So this is the situation now, because this definition will split into two parts, right?
Yeah.
That will be plus x or minus x by x.
Yeah.
So it will be
Correct.
plus 1 or minus 1.
Yeah. Yeah.
Okay, so that is your signum function. So in this case, e power minus x is always positive. So that is just simply constant function 1. Sgn of e power minus x will be 1 only, right? Because e power
Yeah.
minus x is always positive and never 0.
Right.
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 Oh, okay. This was
So it will always be just this much. So that is a
correct.
constant function. Constant functions can be said to be periodic, but the period is not defined, right? Period is
Yeah.
0. I mean, it's constant, right? So it
Yeah.
repeats
Yeah.
after period is 0, you can say, right? Uh,
Correct.
uh, Constant function can be called to be periodic in some sense, right? Every value repeats.
Yeah. Yeah.
The other one, b part, if you see, whenever sin x is less than 0, it becomes minus sin x, right?
Right. Right.
And whenever sin x is greater than 0, it becomes 2 sin x, right?
Correct.
Yeah.
So the
Yeah.
function b will be 2 sin x if sin x is positive, and 0 if sin x is negative, right?
Correct.
Yeah.
So whenever sin x is positive, so if you draw the graph 0 to pi range, right, it will become from 0 to 2 instead of 0 to 1, right?
Yeah.
Correct.
0 to pi range and pi to 2 pi range, and then again 2 pi to 3 pi range, right? Let's think about what is going on. So instead of y is equal to sin x like this, it will become double of that, right?
Yeah.
It will go up to 2, right?
Right.
Instead of going up to 1 only, right?
Yeah. Yeah.
And in the middle portion here, it will be 0, right? Then again it
Right.
will go up to
Yeah.
2,
Yeah.
and then again it will be 0, right?
Yeah. Yeah.
Yeah.
So this is clearly repeating. Period is 2 pi, right?
Yes.
So B is periodic, right? You should
Yeah.
check the answer once. B should be periodic. A and B are both periodic, right? At least so far,
Yeah.
I
right?
think the question is wrong. It should be which of the following is not periodic.
So what are they saying? Answer?
They're saying the answer is
It's
C.
C.
So
Only
C is,
C is saying.
yeah, and C is not
Yeah.
periodic.
So if C you think about, C function is basically what? Minimum of sine of fx and sine of x and mod x, minimum. So if you draw the graph again, draw your sin x graph, and sin x graph looks like this and like this, right? Something like this. Mod of x graph looks like this,
Yeah.
right?
Yeah.
So minimum of this, right? So minimum of this is basically sin x throughout this portion, and then for some time it is mod of x, right? And after that it is again sin x, right?
Yeah.
Correct. So it is not periodic because of this portion.
Yeah, mod, yeah.
Because of this portion, whatever is that region, right? There will be some region like that. Okay. Now, because of which, even though later it becomes periodic, but in this part it will fail. No, whatever you say, the period is, right? It
Right.
will fail in this portion of the graph, right?
Yeah.
Because you have to take minimum value, right? So minimum value graph is now looking something weird like this, right?
Correct.
So even if it works everywhere else, because it fails here, we can say that there is no period, right?
Yeah. Yeah.
You understand?
Yeah.
The other
sir.
option, that is GIF of x plus half plus GIF of x minus half plus 2 times minus x, that we can think about. GIF of x plus half plus GIF of x minus half plus 2 GIF of minus x. Okay. Again, drawing the graph is the best way here, but plus half and all. Well, actually, I think it's a drawing a graph question. So 2 times GIF of minus x. If x is an integer, right? If x is an integer, then this will be x only, no? This part,
Yeah.
right?
Yeah.
The first graph, the first GIF, right? So think about it. The x plus half plus x minus half plus 2 times minus x, right? Something like this is the question, no? Which of the following are periodic? So now let's take two cases. X belongs to integer. If x is an integer, this bracket should become x, right? And this bracket should become x minus 1,
Yeah.
and minus x will, GIF will remain as minus x only. So plus 2 into minus x, right? So this is a constant function,
Yes.
right? In this range at least. If
Correct.
x is an integer, the answer is always minus 1, right?
Yeah.
Yes.
If x is not an integer, right? Then you will have to think about the ranges. So 0 to 1, let's say, right? So split it into portions where you can remove the GIF, right? So I can take 0 to half first, right? Where the sum is less than 1, right? So this is 0 plus 0 to half, so it minus half, so it will become negative. So minus 1 will come here, plus 2 times negative of 0 to x. So 2 times that GIF is minus 1 again. Are you understanding what I'm saying? -1, -2,
Yes, sir.
-3. It between 0 to half, function is always -3, right?
Yeah.
And then half to 1, function will probably assume some different value, right? Correct?
Yeah.
Because
Yeah.
half to 1, this will be still less than 1, so 0. Half to 1, this will be positive, so this will also be 0. Plus 2 into minus half to 1, so -2, right?
Hmm.
So you are getting the function is always -1 at integer points, and different ranges, function is different values, no?
Yeah. Yeah.
It's not periodic then, obviously, right?
Correct.
Yeah.
It is constant till 0 to half, then suddenly it is -3 there, then suddenly it rises up to -2, right?
Yeah.
Right.
So clearly, and then at integer points, it is a discontinuous sort of -1, right? So definitely
Hmm.
no one common value you can get after which you can predict the value, right?
Correct.
Oh wait, can the
Right.
period be 1 though? No, it can't be 1 because it will fail on points which are just less than half and the next points, right?
Yeah.
So not periodic. So think about it in terms of graphs or take cases here. Here I took cases of X inputs. Okay,
Hmm.
what else?
Sir, I have a doubt in 34.
Hmm. Okay, fx is equal to x when x is irrational and 1 minus x when 1 minus x when it is irrational and x when it is rational. Then f of x is given as what? Right? Okay. Fx is defined as x when x is rational and 1 minus x to q irrational. So okay, fine. So if x belongs to q here, f of x, right? If x is rational, f of x should be x, right?
Yeah.
So it will be x only. It will be f of x only, right?
Yeah.
Hmm.
Correct. If does not belong to q, it is irrational, then you will get f of 1 minus x, right?
Correct.
Correct.
Yeah.
So, but since x is irrational, 1 minus x is also irrational, right?
Yeah.
Yeah.
So it will become 1 minus f of 1 minus x is whenever it is irrational, f of x is 1 minus 1 minus
1
x.
minus x.
1 minus 1 plus x it will come when x is irrational.
Right.
And
Right.
when it was rational, it was equal to fx and is equal to x only, right? Fx is x when it is rational, right?
Yeah.
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 So in
Okay.
both
Got.
cases, f of x is equal to x.
Hmm.
Yeah. Got it.
For all numbers, basically, you're getting f of x is equal to x.
Yeah.
Correct.
How are we thinking about it? We are thinking carefully for rational, for irrational separately, and it will be fine. It is coming.
Yeah.
Okay. What else? So how much have you guys done? What all have you attempted here in this?
I attempted the first 35 questions.
Okay.
I could only attempt like till the first 20.
Rishi? Rishi is there, no?
Yeah, so I did like till 30, but then many of the periodic questions also are like,
But now you are understanding
yeah,
it. You
now
get-
Yeah, yeah.
like
Okay, fine. So
Sir, I attempted the first 40 questions in the first exercise. I
Hmm.
tried doing some questions from the second exercise, like here
Hmm.
and there, just so that I can try. So I tried question number 24, but I could not solve it. I have a doubt in that.
24 of second exercise.
Second exercise, yeah.
1 second. Number of real roots of this. That one.
Yes, sir.
Huh? Number of real roots of 3 power x plus 4 power x plus 5 power x minus 6 power x is equal to 0 is R what? Number of real roots. Okay. So you have to think about the number of real roots of this. So basically, 1 plus 1. Okay. 1 is fitting, yeah? No. 3 plus 4 plus 5 minus 6. No, doesn't fit, right?
No.
Yeah, it won't. It doesn't fit.
0 also doesn't fit, right? F of, let's say our function is this. F 3 power x plus 4 power x plus 5 power x minus 6 power x.
yeah,
So f of 0 is coming out to be 1 plus 1 plus 1 minus 1, right?
understand.
So 2, right? And f of 1 is coming out to be 3 plus 4, 7 plus 5, 12 minus 6, 6, right?
Yeah.
And if you go negative x, right, then you are getting, let's say, f of minus 1, what happens? F of minus 1 will be 1 by 3 plus 1 by 4 plus 1 by 5 minus 1 by 6, right?
Yeah.
Yeah,
So it will become, this is clearly positive, right?
Yeah. Yeah. Positive.
And
Correct.
f of minus 2, let's say, will become 1 by 3 square plus 1 by 4 square. Okay, again positive will become. It is obvious. So basically what you're getting is when you get close to minus infinity, then you get 0, no?
Yeah.
Very low values, many very large values, minus infinity and all, then you get
Correct.
0, 0,
Correct.
0, 0, right?
Correct.
yeah, yeah,
The function is always positive first of all, right? So no real roots.
yeah. Okay.
Yeah.
You can also check the derivative of the function. Once we know a little more calculus, we can do it in other ways
Right.
also.
Oh,
But
okay.
derivative of the function will always be positive. You can check. Right now, I'm just checking values and I'm realizing that it will touch 0 only at minus infinity, no, when everything is 0.
Yeah,
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 yeah.
Everywhere else, it is coming positive only. So how will it ever
Hmm.
become equal to 0, right?
yeah,
Mm-hmm.
Okay. You guys should get this one book for yourself right now only and basically try practicing from there. So I'll just tell you, this is a good book. It is called GRB Problems in Calculus by Samir Bansal. Okay. So it is by Samir Bansal. I mean, you will find this book online very easily.
Hmm.
And you should get this book. It is a collection of problems for calculus only. Collection of problems for calculus. You can try problems from this book. So what I will do is I will share a few questions from here.
Hmm.
If you have no more doubts, then I will share the questions.
Yeah.
Once again, just let me search if it is available online, because then it will be very easy. 1 second. Just hold on for a minute. I'll just find out.
Sir, I got the book
Where?
on the website. I can share the link.
Share it in the group
Okay, yeah, just 2 minutes.
or in the chat here. Fine. Chat also is done.
Yeah, just a minute. Yeah, I'm just. It's not letting me share it without downloading, so just a minute.
Hmm.
Yeah, so
You have shared it somewhere.
yeah, I just sent it in the chat. It'll just take some time because it's a big file.
It's the book only.
So yeah, it's the book, the entire book.
Okay. Uh, so you guys can use this or buy a physical copy. That will be better. But for now, you can use this. This is good collection of problems. So just start solving this right away so that you are well prepared by the time the exam comes. Okay. So
Right.
the questions in this book will be slightly tough, but good to practice from here. So I will just share a few questions. Right now we can discuss a few of them.
Mm. So did the book come?
I think it has come now.
Yeah.
It
Yeah,
has some 114 MB, so you guys download it. I have the physical book, so you can download it from here for now, and otherwise buy the book.
yeah, the
Okay.
book's pretty big.
Yeah.
So, for example, one question in the functions chapter, question number exercise 1, question number 4 is if fx is equal to pi root over x plus 7 minus 4 by x minus 9, then range of y is equal to sine of 2 of 2fx. Range of this function is being asked. Okay. And the function definition of f of x has been given. Okay. So try it once. Whenever you need to find range, you should first check the domain once, because domain will give you an idea of what values to check, right?
Yeah.
So domain of this is pretty straightforward. X is not equal to 9 and x is greater than equal to minus 7, right?
Yeah.
Correct.
Yeah,
So
yeah.
basically minus 7 to infinity minus 9.
-1.
That is the domain. And then you have to think about the range of sine of 2 of f of x, right?
Yeah.
Okay. So you need some idea of f of x then, like how much will f of x values be and so on, right? Then only you can predict what 2 of f of x and all will take, right?
Right.
Yeah.
So f of x is equal to pi into root x plus 7 minus 4 by x minus 9. Now, what to do here? I mean, to remove the root, you can rationalize the numerator, right?
Yeah.
root x plus 7 minus 4 into root x plus 7 plus 4 by x minus 9 into root x plus 7 plus 4. So on top will become x plus 7 minus 16, right?
Yeah.
X minus 9 only, no?
Right.
Correct.
Correct.
So this
Yeah.
part cancels. You're getting pi by root x plus 7 plus 4, right?
Yeah. Yeah.
So fx is coming out to be pi by root of x plus 7 plus 4, right?
Yeah.
So since this is positive, you are getting fx is always lesser than equal to pi by 4, right? Correct. So, and fx cannot be 0, no? Fx
Yeah.
can never be 0 because
Never be
numerator
zero.
is positive, right? So you're getting 0 is less than fx is less than equal to pi by 4.
Right.
Are you getting that? Why? Because
Yes. Yeah.
fx is less than pi by 4 clearly, right?
Yeah.
Yeah. Yeah. Yeah. Okay.
And it cannot be what? It cannot be 9, right? X cannot be 9, no?
That cannot be nine. Yeah.
Correct,
Because
correct.
fx cannot be pi by root over 4 plus 4. So pi by 8, right?
Yeah. Yeah.
Fx cannot be pi by 8. Other values are all fine. And it has to be less than pi by 4. So, and it cannot be 0. Basically, fx value is from 0 to pi by 4 minus pi by 8, right?
Yeah.
So 2 times fx will go from 0 to pi by 2, right? Correct?
Right. Right. Yeah.
Right. And you will have to exclude pi by 4.
Yeah. Huh.
2fx can never be pi by 4, no?
Yeah.
Yeah. I
Right?
can't.
Because fx can never be pi by 8, right?
Yeah.
Correct.
Now that has been input to sine function, right? This whole thing, right? So the output will be from 0 to 1 except 1 by root 2,
Right. Yeah. Okay.
right? And
Right.
it can
Correct.
include 1, it cannot include 0.
Correct.
It
Yeah.
cannot
Yeah.
include 0, it can include 1, it cannot include 1 by root 2.
Correct.
So that is question number 4 in level 1 exercise of this. Then just I want you guys, since you have the PDF now, I want you guys to go through the exercises of this function chapter, okay?
Yeah.
Yeah.
Because through the problems only we can discuss whatever theory is left, because I don't need to take separate theory classes and now we can just
Okay.
do the problems here, because mostly all the theory is done. If there is something new that will come, we'll see it in the problems, right?
Right. Right.
Yeah.
Yeah.
So let's look at some other question. Let's look at, for example, question 11. If you guys can, you guys have the PDF open now, right?
Yeah.
uh, or question 11 seems straightforward quadratic, so let's not look at that then.
Yeah.
Let's look at question 15. Question 15 looks weird. If a polynomial function f satisfies this relation, satisfies log 2,
Exercise is this one?
this
Is
is
that
first exercise.
first exercise? 11th.
First exercise,
15.
15th one.
15th. Yeah.
Log 2 f of x. He has not mentioned it as GIF, so I'm assuming it is not GIF. Is equal to log 2 plus 2 by 3 plus 2 by 9 plus so on till infinity, multiplied by log 3
Yeah.
1 plus fx by f of 1 by x, right?
Yeah.
And he is also given f of 10 is equal to 1001. Okay, he is asking you to find f of 20, right?
Right.
Yeah.
Okay, so first this relation looks weird, so first let's simplify this part a little bit.
Yeah, that's a
So
GP.
this is clearly a GP,
GP.
3 power 0 and 3 power 1, 3 power 2 and so on. So the sum of this GP will be, first term is 2 by 3, 2 by 2. 2 is the first term, common ratio is 1 by 3, right?
Yeah.
Yeah.
The
Yeah.
sum's 3.
Actually it is just 2 by 1 minus
1
1 by
minus
3,
1 by 3, so that's 3.
2 by 2 by 3, so it is 3. So
Yeah,
this is log 2 3 log 3 1 plus fx by f of 1 by x, right?
we can change the base now, right? We can write it as uh 1 by log.
So it can be written as log 2 1 plus fx by
Yeah,
f of 1 by x. Why? Because I'm writing this part as log base e by log base e2, right? And I'm writing this part as log of this bracket by log of 3, right?
right.
Yeah.
So log 3 cancels and it is log
Yeah.
something by log 2, which is log base 2 this, right?
Okay.
So
Correct.
finally you're getting fx is equal to 1 plus fx by f of 1 by x, right?
Yeah. Yeah.
Correct.
Yeah.
So therefore you're getting multiply by f of 1 by x throughout, getting f of x into f of 1 by x is equal to f of x plus f of 1 by x, right?
Yeah.
Correct. So you have
Yeah,
sum of the functions is equal to the product of the function, something like that, right?
Right.
This
Right.
this is a very common functional equation, but let's try to think about what functions will satisfy this, right? Think of what satisfies something like this, right? That is our job. Uh, so I'll just write it on the next page. F of x into f of 1 by x is equal to f of x plus f of 1 by x. This is what we have gotten, no? Right? And we also have f of 10 is equal to 1001. And you're supposed
Yeah.
to find f of 20,
Right.
right?
Yeah.
Okay. Now fx is a polynomial function, so it will be something like this: x power n plus a1 x power n minus 1 plus a2 x power n minus 2 and so on, right? Plus a1 an x an minus 1 x and a1 an, right?
Yeah. Yeah.
Correct.
This is my polynomial, right? Okay. Now f of 1 by x will be the opposite polynomial, right? F of 1 by x will be 1 plus a1 x plus a2 x square plus so on plus an xn by xn, right?
Yeah.
Right? I've just put 1 by x and simplified,
Yeah. Yeah.
right? So if I multiply these two, right? If I multiply these two, I'm supposed to get the sum of these two, right? Which is slightly
Right.
weird. So let's think about it. I'm multiplying x power n plus a1 x power n minus 1 and so on till a n minus 1 x plus a n multiplied by 1 plus a1 x plus a2 x square plus a n minus 1 x n minus 1 plus a n x n, right?
Yeah.
Divided by x power n
That's correct. Right.
should be equal to fx plus f of 1 by x, right?
Yeah. Yeah.
So should be equal to this plus this. So when you do plus, the x power n multiplies, right? So you get x power 2n plus a1 x power 2n minus 1 plus a2 x power 2n minus 2 and so on plus an minus 1 x power n plus 1 plus an xn plus an xn again plus
Yeah.
an minus 1 xn minus 1 and so on till a2x square plus a1x plus 1 divided by x power n, right?
Yeah.
Yeah.
Correct.
I've just added, okay, nothing I've done. Cancel the x power n. Now see, you are getting x power n, an x power n here also, right?
Yeah.
Correct. So you're getting an x power 2n, right? This side. An x power 2n. Coefficient of the term x power 2n is an, no?
Yeah. Yeah.
That is the 2n power term, no? What is the
Yeah.
2n minus 1 power term? I have to multiply this with n power here, correct? And
Yeah.
this with n minus n power here, right?
Yeah. Yeah.
Yeah, correct.
So you should get a1 an, right,
Yeah.
plus an minus 1 into 1, right?
Right.
X power 2n minus 1. And here we have this particular series, right? So first of all, you see that if they have to match, then an has to be 1, right?
Yeah.
Right? If they have to match, an has to be 1. And then you are seeing that a1 into an plus an minus 1 should be equal to a1, right?
Yeah. Yeah.
And an is 1, then this is gone. So a1 is gone, so an minus 1 is 0, right? Are you seeing that an minus
Right.
1 is 0,
Zero. Yeah.
Yeah.
right? For sure you're getting that, right? After just multiplying and checking, comparing coefficients, right?
Right.
Yeah.
Let's look at the constant terms on both sides. Okay, constant terms on both sides. So there is an an here and there is a 1 here, right?
Yeah.
Right, that is the term. And on this side there is a 1 here. Okay, that proves again that an is 1, right?
Right. Yeah.
Correct. Let's look at the term with the x coefficient only. Okay, basically what I'm saying is there any other term that we can think of? Obviously we can think of an minus 2 and so on, but what I just want to confirm for myself is that, okay, I have proved an is 1, I have proved an minus 1 is 0. Similarly, you will be able to compare coefficients and prove that all other coefficients are also 0, a2, a3. Only the coefficient here is 1 and here is 1.
Right.
Yeah.
See, first coefficient and the last coefficient I have done. Okay.
Yeah. Yeah.
You can confirm for yourself, do it properly in your notebook, take a third degree polynomial and confirm, right? Take a cubic and confirm, right? Assume n is 3. Check when is this relation true, right? You will realize that it is true only when the function is x power n plus 1.
Yeah.
Okay. No other coefficients will be present. This will be 0, this
Right.
will be 0, this will be 0, and so on.
Yeah.
So
Yeah.
here, see, it fits x cube plus 1. No?
Mm-hmm.
F of 10 will be 1001 if x power 3 plus 1 is the function, right?
Yeah.
So f of 20 will actually be 8001. Okay.
Yeah.
In the book, if you see in the book, just before the exercise, there is a set of results without proof. Okay. Just before the exercise, I think. 1 second,
Yeah.
let me
Yeah.
just see. f of x plus f of 1 by x is equal to, okay, wait one second, let me just check once. The type of equation that we saw just now is called a functional equation. They are generally hard to solve. Okay, see, look at the book, the theory section, point number 3. Okay, in page number 2 or something, just after polynomial functions.
Yeah.
So point number 3, there is a note number B, right? Is saying there are two polynomial functions satisfying the relation f of x into f of 1 by x is equal to f of x plus f of 1 by x. Which are the two polynomials? F of x could be x power n plus 1, or it could also be 1 minus x power n. Okay, so basically the thing that they're saying is x power 1 plus minus x power n. 1 plus minus x power n satisfies this functional equation.
Right.
Yeah.
But he has not given a proof. We have done a tentative proof. We have gotten the highest coefficient, we have gotten the constant term and all, right?
Yeah.
Right.
So generally the proof will be like this. So you can verify it for yourself. So that is a fact that is used in this problem. All of the rest of the stuff, like all of the log stuff, was just there as a distraction. Ultimately, it was about this thing, right?
Yeah.
So once you get this thing, can you realize that my polynomial must be x power n plus 1 or 1 minus x power n, something like that.
Yeah.
Right.
So
Right.
there is some useful results in the sections before. Okay, so there is some theory section which is basically a collection of results. You should try and understand those. Like you can read through that and try and understand, and if not you can ask me or try to prove them yourself. If there is some
Yeah.
weird result there, try to prove it yourself and go through the exercises with the intention of, like, each problem might be something you can learn something from, right? So attempt the exercises as much as you can. It will take time to solve questions in this because they are slightly hard. Okay, so
Yeah.
you'll have to attempt it properly. This is for advanced only, so
Right.
keep
Okay.
that in mind and attempt it. Okay.
Yeah.
Okay, that's all for now. We'll continue one or two more classes probably on problem solving for functions, and after that we'll start limits. In
Okay.
Alan, what are they doing right now?
So we have a break. We have a
Till
break
when?
till 8th of April.
Okay. No classes are happening. Nothing.
Only some
Like
doubt
dance
class.
class.
Okay, fine then. So keep working on functions exercises for the next week or so, because this is going to be super important. Like right now, if you make it strong, solve this book, everything will be sorted later. If you leave it for later, there will not be enough time. Okay,
Right.
like
Yeah.
there will be difficult chapters which build on this. Like this understanding right now is very crucial. We'll probably start limits and all soon, but there is no rush. You have to do it properly. Okay,
Yeah.
Also.
that's all for now then. Bye.
Okay. Thank you, sir.
Thank you, sir.
Mm,
Bye, sir.
bye.